All right, on to 3.8, solving quadratics with complex solutions. So heads up, this is exactly the same from what we did in last section. The only difference is that we're going to get a different type of root in our answer. So let me start with this question right here. What if we look at some graph that's of this form, this standard quadratic form that we've been dealing with, and the graph looks something like this. And I ask you, all right, solve it, find the solutions, or find the roots, or find the zeros, same thing we did last time. Solutions or roots or zeros, that's where it crosses this x-axis right here. Big fat question mark. What if you graphed it, and you looked at the graph and said, okay, Miss Kate, that never crosses the x-axis, there are none. To which I would respond, well, that was when we were working on what we call the real quadratic, or no, I'm sorry, the real plane, the real coordinate plane. You have your x values and your y values, and last time we got either 2 real solutions or 1 real solution. We were working in the numbers that we're normally working with, but remember back to us working with imaginary numbers. This graph right here that you're looking at has a root or has a solution, but it's on what we call the imaginary axis. Now there's a video that I linked in the same place that you found this video on Canvas that visualizes what the imaginary axis looks like. I encourage you to watch that. You may want to just pause the video right now and go back and watch that video. It'll help you visualize what's going on. What I mean by there are imaginary solutions. Not that I'm making up numbers and kind of like an imaginary friend, you just like make up somebody. I'm not making up this. This is like a real mathematical concept. This graph that you're looking at does have solutions, it's just on the imaginary axis. It kind of opens the door to different types of math that we can do. So again, the solutions that you're going to get in this section are not real solutions. They are imaginary solutions. So we're not going to get real solutions. We are going to get imaginary solutions. Meaning we're going to have complex numbers. Remember, a complex number was in the form of a plus bi, so it might look like that. It might look like just something like 2i or the square root of 2i, something like that. So let's just jump right in and see a couple of examples of what I mean by this when you're going to get imaginary solutions. Let's look at example number 1. And we're going to have 3x squared plus x plus 4 equals 0. Nice thing about this one is it's already of this form right here. Just like last time, we want to make sure it's in this form set equal to 0, and it is. So my a value is 3, my b value is 1, my c value is 4. So I'm going to use that in my quadratic equation. So my quadratic equation, I might use this color here. My quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, plug those values right into that equation. Negative b will be negative 1 plus or minus the square root of 1 squared is 1 minus 4, a is 3, c is 4 all over 2a. Okay, keep simplifying. Now we're going to get negative 1 plus or minus the square root of 1 minus, let's see, we've got 12 times 4, that's going to be 48 if I'm not mistaken. All over, oh, I didn't even plug in a for down here, so 2 times a is 3, so I'm going to have over 6. Okay, perfect, so yeah, that looks good, right? 4 times 3 is 12, times 4 is 48. Okay, so let's keep going. I've got negative 1 plus or minus the square root of negative 47 over 6. Uh-oh, can you take the square root of a negative number? No, unless we work with our imaginary numbers. Remember, I equals the square root of negative 1. So we can pull an I out of this right here and turn it into a positive radical. So what that looks like is I'm going to have -1 plus or minus. I'm going to pull out an I, and I'm left with the positive version of 47 over 6. Now 47, I can't factor that anymore. Like I can't simplify that radical anymore, so I'm going to leave it as that. So this crazy weird number, actually there are two, right? Because you have plus or minus. These are your solutions. They are imaginary because you have this I right here. So now we have two imaginary solutions. So this graph is going to look like it doesn't cross the x-axis on a normal coordinate grid, but it does on the imaginary axis. Okay, let's try another one. Let's do number 2 right down here. Okay, let's say we have -5 equals x squared plus 4x. Okay, I'm going to get it to look like what we've been getting it to look like. I'm going to have x squared plus 4x plus 5 equals 0. Okay, my a value is 1, b is 4, c is 5. Plug it into the quadratic formula, so I'll have -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I've got -4 plus or minus the square root of 16 minus 20. Oh, we're going to get a negative in there, which is fine. We know how to deal with that. -4 plus or minus the square root of -4 over 2. Okay, over to the side, I'm going to kind of think, all right, I've got the square root of -4. Now, I can pull out an I and make it I times the square root of 4. I also know the square root of 4 is 2, so I can just say 2I. Okay, so I'm going to simplify that. So this turns into -4 plus or minus 2I over 2. Cool. Now wait, we can simplify that even more because this is divisible by 2, this is divisible by 2, and this is divisible by 2. So I get -2 plus or minus I over 1. So I could just leave it like this. -2 plus or minus I. Because I have plus or minus, I have two possible solutions, and they are imaginary because I have the I in there. Two imaginary solutions. Okay, perfect. And let's try another one. Let's try number 3 right here. Okay, let's do this one right here. We've got 2x squared plus 8 equals 0. Okay, we want it of the ax squared plus bx plus c equals 0 form. So what I can do, like we did on the last section, I can force there to be, that middle x value, that bx, but b would be 0, right, because it's gone. Okay, so my a is 2, my b is 0, and my c is 8. Okay, so -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, -0 plus or minus the square root of, we're going to have negative 8 times 8 is 64 over 4. Simplify more. That can go away. -0 is 0. So I'm going to have plus or minus the square root of -64 over 4. Now, the square root of -64 equals, well, plus or minus 8, right? The square root of 64 is 8, and then I have an I there because there was the negative over 4. Keep simplifying because I can pull out a 4 from both of these. And I'll be left with plus or minus 2i. Okay, because I have plus or minus, I have 2 imaginary solutions. Perfect. All right, and so we can just kind of keep doing this. Maybe we'll do one more example. Now, I will warn you on your homework, you're going to get some big numbers to work with. But don't let that scare you. You do the exact same thing. So let's see. Let's look at maybe this one, number 4. Okay, I'll have x squared minus 4x plus 13 equals 0. It's already up the form I wanted in. My a value is 1, b is negative 4, c is 13. Perfect. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplify, it'll be positive 4. Plus or minus the square root of 16 minus, let's see, 13 times 4 is 52 all over 2. Keep simplifying. I've got 4 plus or minus the square root of, what's that going to be? Negative 36, maybe? Okay, over 2. All right, which equals 4 plus or minus. There's going to be an I in there because it's negative. And actually, the square root of 36 is 6. So I'm going to say 6i over 2. And again, simplify. All these are divisible by 2. So I'm going to have 2 plus or minus 3i as my 2 imaginary solutions. Okay, cool. Now again, you're going to get some really nasty numbers on the homework. It's just big numbers to work with, but you can handle them, right? Okay. Now, the thing I want to show you here is I'm even going to jump back and forth between these notes and section 3.7's notes because there's something really interesting that you're going to find. Okay, I want you to look at what is underneath the square root of each of these problems when we plug it all into the quadratic formula. For instance, what I'm saying here is this value right here. When I plugged all of this into the quadratic formula, underneath the square root, I got a negative 36. And my types of solutions was 2 imaginary solutions. Negative number under the radical, 2 imaginary solutions. Up here, this problem, negative under the radical, and my answer was 2 imaginary solutions. Okay, let's do another one. Here, I had a negative under the radical, and I had 2 imaginary solutions. Okay, and again, I had a negative under the radical and 2 imaginary solutions. Okay, Miss K, what are you getting at? Okay, let's go back to the other notes. I want to show you something. Let's go back to 3.7. And let's go up. Let's go up to what we had up here. All right, up here, and whatever problem this was, I have no idea. I had a positive under the radical, and my answer was 2 real solutions. Okay, I had a, let's find this one. I had a positive under the radical, and I had 2 real solutions. Okay, let's do another one. I had a positive under the radical, and I had 2 real solutions. Okay, catching on. Here, another one. I had a positive under the radical, and I had 2 real solutions. Okay, so what I'm seeing is if I have a positive under the radical, I have 2 real solutions. Going back, if I have a negative under the radical, I have 2 imaginary solutions. Okay, going back again, but wait, Miss K, we also had an example where we had one real solution. Let's look at that one. One real solution happened when I had 0 under the radical. 0 under the radical meant one real solution. So there's a pattern. Based on what is underneath the radical, you can automatically tell if you're going to have 2 real solutions, 1 real solution, or 2 imaginary solutions. So let's flesh this out a little more. Going back to these notes that we're working on right now, I'm going to jump up to this chart right here. Okay, your discriminant is this value right here, which was underneath the radical. Whatever is underneath the radical, I'm even going to write that. Okay, what's underneath the radical is called your discriminant. I don't need you to know that, but I do need you to know the concept. If what is underneath the radical is greater than 0, is a positive value, okay, when we had a positive value, we had 2 real solutions. Oh, sorry about that, guys. Let's see. Let's open this up again. Okay, here we go. Back in business. All right, again, what was ever under the radical was positive or greater than 0. We had 2 real solutions. Okay. Over in the second column, if it was equal to 0, which we only saw one example of that, you had 1 real solution. If whatever's under the radical was less than 0, when we had negatives, we had imaginary solutions. We had 2 imaginary solutions. So if you're not already, copy this in your notebook. This is super important because you can tell right off the bat, just by looking at what comes out underneath the radical of your quadratic formula, what types of solutions you're going to get. Kind of a way to check yourself, maybe to check your answers. And two, it helps you visualize what's going on in the graph. So down to this third row, if I have 2 real solutions, I'm going to have a graph that looks something like this. And we've talked about it, where it has solutions or it hits the x-axis at 2 spots, 2 real solutions. If you have something like this, where it hits the x-axis at 1 spot on its vertex, you have 1 real solution. And then if you have a graph that looks like this, like where it's up, out, in, nowhere, or maybe it's also down, below, and it never crosses this x-axis, it never will get there, then you have 2 imaginary solutions. Hopefully you watch that video and you watch what's happening like visually in 3 dimensions when you have an imaginary solution. It's kind of like you're adding a dimension onto math. Okay. Cool. So, again, 2 real solutions right here, 1 real solution right here, 2 imaginary right here. Okay. Cool. So that's about it. And again, your numbers are going to be a lot bigger on your homework. Don't let that scare you. Treat it the same. Do the quadratic formula and go from there. I think the hardest part is simplifying your quadratic formula and then tell me if you have 2 real solutions, 1 real solution, or 2 imaginary solutions. And you have 18 problems on your homework, and it is pretty dense. You get some big numbers, like I said. So hang in there, take your time on it, do the best you can, and send me any messages that you've got. Good luck.